Today I'm going to demonstrate how the tapered thread turn using NX CAM. Check up this video. I found one datasheet in the internet, and for the 25E standard tapered thread, let's see what are the thread parameter for the 25E thread. Okay, here you can see the thread profile detail, and here you can see the thread parameter like major, minor diameter and tapered angle. So now first we need to model the tapered thread section based on the parameters which found on the datasheet. So I set up new file for the 25 thread. I will show and start sketching the thread section based on the major, minor, taper angle listed on the data sheet which we have found. So let's sketch the thread section. You can find the parameter data in the data sheet. Also adding additional turning section to the hold the stock, the turning part. First I draw the major diameter of the threaded section. Now revolve this part. I'm going to color the threaded section. Okay. In data sheet you can see minor diameter for the threaded. There also you need to draw minor diameter angle tapered line in the sketch, because in NX turning CAM we need in later in order to provide tapered angle. Okay, I draw the tapered minor diameter tapered line, and I colored red as for the minor diameter line for the better visibility. Okay. Now we have everything, and let's go to the manufacturing wizard in NX. I'm going to turn the part. Let's delete some of preset of unnecessary things. Okay, first we're going to define the MCS based on the CNC turn setup. Okay, then define the part and stock. I take the stock diameter as 30 and kept the 2 mm for pacing. And I will hide the stock part and revolve part for better visibility. First I'm going to add containment to limit the tool motion on unwanted area without going for the unwanted area for safety. Beyond this 70 mm, the tool fixture hold this turning part. Now we will add avoidance as usual turning setup. I'm giving just start point and motion type setup without going any detailed setup for the avoidances. Okay, first we will going to paste the part because we kept 2 mm for pacing, and define the tool. Yeah, based on your tool library, tool insert and tool angle, you have to define the correct parameter based on the catalog detail you have. And then I'm going to define some necessary parameters before generating the pacing. You can set the feed rate and spindle speed, surface speed, and stock, and let's generate. I kept the stock 0, so it's like finishing. You can simulate now. Okay, we have done the pacing. Now we're going to rub the turn part. We have to remove the material in the tapered area. Use the same tool that we use for the facing operation. And define some parameters, cut depth, because main of the purpose of this tutorial is to how to set up the tapered threading in turning. So define some speed. This is a wrapping operation. We have to hide the adapter, tool adapter. You see the tool path only generate up to the containment boundary limit. Okay, initial wrapping is done. Now we have to wrap the backside inner section of the cylindrical part. This is simulation. Okay. We're going to use back turn, wrapping back turn. Yeah, I have to set new tool with a different angle because we are going to turn the back side of the part. It's side adapter. And it seems okay, tool orientation and parameter for me, but if you need to define the correct parameter with catalog. Then we are also going to define some other necessary parameter. Speed, cutting depth, stock are the necessary parameters. Then first generate the tool path. We have to correct the region, define the region that need to machine. Okay. In approach, you have ability to define how the tool need to be approach and departure after machining to the part and after machining the part. And generate, and let's check for some collision, tool collision. Okay, not good. I will rename this operation as a backside back turning. Okay, now finish the rough areas with the finishing operation before go for the threading. I use the initial tool for finishing. First, let's finish the threaded area. Let's reduce bit rate. Okay, we need to adjustment on corners to have sharp. By default it's radius. Okay. In this setup we can get the sharp corners. And you can simulate. And also let's finish the back turn area also by copying same rough operation, and we can change those operation parameters to finishing. Here we are only set up in all the main necessary parameters only to demonstrate. Okay, generate and simulate. You can check also any collisions. Okay, all set, and now we can turn the 25E thread. This time we going to use the thread turn operation for outer. Thread OD. the threading tool, we need to define the threading tool. Rename the operation, and first we need to define the threading tool. We need to define tool parameter that need to match with the, actually you need to find the correct tool for the thread profile to match to the thread profile. This angle is 55, LA and RA angles are divided by 35. Okay. Now need to define the tool orientation. The tool orientation that need to perpendicular to the thread tapered angle. If you go to the tapered angle is 6 degree 52 minutes. Can convert into the then 6.86 degree angle. You can set the tool orientation angle. That need to okay. Now the tool orientation is perpendicular to the taper angle. Now tool is defined. Okay. Now we need to select the crest line. You can select the tapered major diameter is the crest line, and select the end, and you can select the depth option as root line, and root line should be the minor angle that we have drawn in the second escape when we start. And set some parameters, depth of cut, and define the turning speed. For thread milling, normally use the lesser RPM and speed, and now you have to set the pitch for the thread. You can find the in datasheet nominal pitch is 1 point. In pitch selection window you have different option to set the pitch. Okay, all the necessary setting parameter defined. Let's generate. In NX thread turning simulation only shown as a linear line. You cannot see any graphical simulation to show the thread. You will try with actual CNC turn to see the output. Thank you.